Everyone, welcome you all on this session, and this is Nityanand Misra, and today we are just going to cover engineering mathematics 3 unit first, the sum of some important topics from unit first. And so let us see about the first is formation of PDE. Okay, so at here we are seeing just the two term, that is the eliminating arbitrary constant and eliminating arbitrary function. Okay, and another is Lagrange's linear equation, and that is the form of Lagrange's linear equation, that is PP plus QQ, that is equal to R. And in another video we are just see about method of separation of variable. So let us see some standard notation whenever you see that is del z by del x. So consider that term, that is equal to P, and same as it is del z by del y, that is equal to Q, del square z by del x square, that is equal to R, del square z by del x del y, that is equal to S, and del square z del y square, that is equal to T. Okay, so that is the official format of Lagrange's equation. Okay, and whenever you have to find order and degree, you just see about the highest time difference, partially differentiate any PDE, that is known as the order, and in the order the highest power is known as the degree. Okay, so let us see form the PDE by eliminating arbitrary function. So here is the question number first, and here the function is given by f x plus iota t plus g x minus iota t. Okay, and we have to solve this function by the eliminating by the arbitrary function. Okay, so let us see at here given, that is the function as it is, and consider this function as equation first. Okay, now we have to differentiate partially with respect to x, and we find that f dash of x plus iota t and plus g dash of x minus iota t. Okay, again we have to partially differentiate this equation with respect to x, and we find that f double dash of x plus iota t plus g double dash x minus iota t. And now we have to differentiate partially equation first with respect to t, and we are using at here chain rule. Okay, you must have to know chain rule. So let us see it here. So from chain rule, that is become something like that, f dash x plus iota t, and from here by the chain rule into iota plus g dash x minus iota t, and here minus of iota. Again we have to differentiate partially this equation with respect to t, and we find that f double dash of x minus iota t into t square with chain rule. Okay, and y double dash x minus iota t into y square. Okay, I square, and we know that iota square, that is equal to minus 1, and when we just shifting minus 1 at the place of iota square, that will finally become something like that, minus of f double dash x plus iota t and minus of g double dash x minus iota t. Okay, so from here by adding equation second and third, and we see in equation second that overall term is in plus, and in the equation third the overall term in the minus, so that is cancelled to each other, and finally our equation become del square z by del x square, and we just adding equation second and third, so obviously there is the plus sign, so that will become del square z by del t square, and that is equal to 0. So that is the required PDE for this equation. Okay, so at here you see how simply we solve this question. Okay, so let us see question number second. and question number second something looking like okay. So here is the function z, and that is equal to x plus y and plus of x f of xy. Okay, and here f of xy is undefined, we don't know about f of xy, so consider it as it is. Okay, so here is the given function, that is z is equal to x plus y plus f of xy. Okay, and consider this into equation first. Now partially differentiate this first equation with respect to x, and we know that the del z upon del x by del x, that is equal to 1. So from here 1, and we know that that is the constant term, so that is 0, and I am not writing here at 0. Okay, so you consider, and plus of, we know that that is the undefined function, it is not defined that what is the value of x y. Okay, so f dash of xy, the partially differentiation of this term, and now we have to just differentiate partially xy. Okay, so del by del x of xy, so we know that del by del x, that is equal to 1 and y as it is right here. So let us simplify this equation second. So we know that del z upon del x, that is equal to p. Okay, so that is equal to p, and from here we write p is equal to 1 plus, and this term shifting at here, so y of f dash xy. Okay, and finally it become p minus 1 y times f dash xy, and consider this into equation second. Okay, equation number second, and now one more time we have to differentiate partially equation first with respect to y, and from here we know that the x term become 0 and y become 1. Okay, and f dash of xy into x as it is, as like equation first with respect to x. Okay, so same as and we know that del z upon del y, that is equal to q. So from here we write q at here, and after simplify this equation look like something. Okay, so that is so consider this equation into equation number third. So now we just see it here, that is there has a term x f dash of xy and y f dash of xy. So from here we just have to by the subtraction that will not cancel to each other, so we have to just divide it here. Okay, so let us divide equation number second by third, and from here p minus 1 q minus 1, and that is y time f of x xy and f x time f dash of xy, and from here xy and xy cancel to each other, and by the cross multiplication that will become something like that, and that is the our overall equation from here, and that is the required PDE for this equation. Okay, so at here you see how simply we solve the question number second. Okay, by the arbitrary elimination of arbitrary function, and let us one of the important topic from the unit first, that is the Lagrange's linear equation. Okay, so ever ask in your examination, write short notes on Lagrange's linear equation, that is a 7 marks question. Okay, and if there has added one problem, that will become a 14 marks question. Okay, so let us see Lagrange's linear equation. Okay, the standard form of Lagrange's linear equation, that is pp plus qq is equal to r. Okay, and let us see the steps to solve this Lagrange's linear equation. So in step first we have to just compare with a standard form and find pqr. Okay, so and next term, that is the right its auxiliary equation, and auxiliary equation looks something as like that. Okay, dx by p, that is equal to dy by q, and that is equal to dz by r. Okay, and now in the step 3 solve and find the two solution u and v. Okay, and then write in the form of phi u v that is equal to 0. So let us see problem based on the Lagrange's linear equation. So solve p 10x plus q 10y is equal to 10z. Okay, so that is a very easy question, I think. And so let us see it here. Given that 10x p plus 10y q and that is equal to 10z, and we see it here that is in the form of Lagrange's linear equation by comparing this equation into pp plus qq is equal to r. So at here we just find that therefore that is p is equal to 10x, q is equal to 10y and r is equal to 10z. Okay, and after that writes auxiliary equation. By the right auxiliary equation, that is del x by p, del y by q and del z by r, and that is looking something like that. Okay, and by equate equation first and second ratios. So by equating only these two ratios, we find that dx by 10x and dy by 10y. So that will become, that is the differentiate term, and we know that 1 upon 10x and 1 upon 10y, and we know that 1 upon 10x that is the cot x into dx, and 1 upon 10y that is cot y into dy. Okay, and by integrating both sides we find that integration of cot x dx that is equal to integration of cot y dy. So from x differentiate with respect to x and with a function, cosine function, so that will come from log sign. Okay, log of sin x and that is log of sin y, and that is the integration term c, so that is considering as log of c1. Okay, so from here by solving this we find log of sin x by sin y that is equal to log of c by log to log, and from here sin x by sin y that is equal to c1, and considering this term is u. Okay, and now we have to find v. So for finding v, equating just equation number equating just second or third ratios. Okay, so from here second and third ratios, by here we are finding differentiating that term by cot y into dy, that is equal to cot z dz. Okay, and now integrate this term. So from here we find that log of sin y that is equal to log of sin z plus a constant term c1. Okay, c2. From here just okay, so from here you just find that sin y upon sin z that is equal to c2, and consider that thing into v. So we know that the Lagrange's equation is given by phi u v is equal to 0, and our overall answer become something like that. So that is the final answer of this question. Okay, so in another video we just cover the another topic, method of separation of variable. So thank you, keep watching.